Assalamu alaikum, dear students. Let's continue with the chemical kinetics chapter and we'll continue the numericals based on half-life and rate constant of first order reaction. Show that in a first order reaction, time required for completion of 99.9% is 10 times of half-life of the reaction. In this question, what they are asking is, you have to prove that the time required for 99.9% completion of first order reaction is 10 times of half-life of the reaction, that is T half, 10 into T half or 10 into 50%, T 50%, right? So you have to prove that the time required for 99% completion, 99.9% completion of reaction is 10 times the half-life of the reaction, right? So for this, what we will do is we will take the rate constant expression k is equal to 2.303 divided by t log of r naught by r. As we know that k stands for rate constant, t is the time, r naught initial concentration, and r is the amount of reactant left out after time t, right? So here, when it is given time required for T 99.9%. So I'll substitute here 2.303 divided by, I'll write here as T 99.9%. Meaning is R naught will be 100, initial concentration we take it as 100 divided by how much reaction has completed? 99.9% reaction has completed. So how much will be left out? 100 minus 99.9. It will be nothing but you will be left out with 0.1, right? So here it will be 0.1, right? So now k is equal to this relationship you will get. Now we know that half-life is equal to T half is equal to 0.693 divided by k. Okay, so I'll replace k in terms of half-life. So k becomes equal to what? T half is equal to 0.693 divided by k. So k will be nothing but 0.693 divided by T half. So I'll write here as 0.693 divided by T half. That is equal to 2.303 divided by T 99.9%. 100 divided by 0.1, it will be nothing but here 1000. So log of 1000 will be log of 1000. how much you will get? It will be equal to 3. जितने zeros आएंगे वो log value वही रहेगा, क्योंकि multiples of 10 में easily आप log value बोल सकते हैं. log of 1 होता है 0, log of 10 होता है 1, log of 100 होता है 2 and log of 1000 रहेगा 3, right? तो जितने zeros आते हैं वही log value आएगा. कितने zeros हैं यहाँ पर? 3. So it will be having log value as equal to 3, right? So here 0.693 divided by T half, that is equal to 2.303 divided by T 99.9% multiplied by 3, right? So rearrange कर लेंगे. T 99% लेफ्ट साइड पे लेता हूं मैं, is equal to 2.303 multiplied by 3 into T half को मैं राइट साइड में लेता हूं, डिवाइडेड बाय 0.693 नीचे आएगा. So multiply 2.303 with 3, you will get 6.909 divided by 0.693 into t half. Right? So that is equal to 6.93 and here 0.693 and here it is having 6.909, means if you divide you will get almost equal to 10, right? अगर आप डेसिमल यहाँ पे शिफ्ट करेंगे तो 10 रेज टू -1 आएगा. 10 रेज टू -1 ऊपर लेके जाओ, okay, it will become 10 raised to 1 and these two will cancel, you will be left out with almost 10, right? So here when you calculate you will get almost here T 99.9% equal to 10 times of T half, right? So this is the way you have to compare different periods of time. For completion of a first order reaction you require almost 10 half-lives, right? For completion of a first order reaction you require complete almost 10 half-life of time. Okay, next question. For a first order reaction, show that time required for 99% completion is twice the time required for 90% completion of the reaction, right? Same type में है. What you have asked is they are asking time required for 99% completion of reaction is twice the time required for 90% completion of first order reaction. Okay, so same way we will do here. First we'll find out the relationship for T 99%, then we'll take out a relationship for T 90%, then we'll take the ratio. Okay, तो यहाँ पर K is equal to 2.303 divided by T log of R naught by R. Okay, K is equal to 2.303 divided by T 99%. I'll take log of T 99% means 99% reaction has completed. So R naught will be 100. 99% reactant has completed. So you are left out with 1%, means R will be equal to 1. Right? So K is equal to 2.303 divided by T 99%. Log of 100 will be nothing but 2. Okay, or T 99% is equal to 2.303 divided by K multiplied by 2. You keep this one as it is, right? You got the value of T 99%. How much it is? 2.303 into 2 divided by K. In the same manner, find out what will be the relationship for T 90%. So K is equal to 2.303 divided by T 90% log of R naught value again 100. R value will be 100 minus 90. It will be 10. Right? So 10 ones are 10 tens are. So you will be getting log of 10. Log of 10 will be how much? 1. So K is equal to 2.303 divided by T 90%. Log of 10 is 1. Or you can write T 90% is equal to 2.303 divided by K, right? Into 1 is nothing but as it is 2.303 divided by K, right? So now you know T 99% and T 90% relationships with K. You can take the ratio of T 99% divided by T 90%. So what we will be getting is T 99% divided by T 90%. It will be equal to what? T 99% कितना मिला हमको? 2.303 multiplied by 2 divided by K मिला. T 90% कितना मिला? 2.303 divided by K मिला. तो यहाँ पे डिनोमिनेटर में है तो यहाँ पे रेसिप्रोकल हो जाएगा. तो यहाँ पे आएगा K divided by 2.303. Cancel. K and K also cancel. As it is a rate constant, it will be constant. So you are left out with T 99.9 T 99% is equal to, take this side, 2 into T 90%. Hence it is proved, right? So time required for 99% completion of reaction is twice the time required for 90% completion of the reaction. Okay. Next question. Show that in a first order reaction, time required for completion of 75% reaction is twice the half life of the reaction. ये भी सेम टाइप में है. What they are asking is T 75% is equal to 2 times of half life. Okay, चेक करेंगे. पहले रेट कांस्टेंट का एक्सप्रेशन लिखेंगे. 2.303 डिवाइडेड बाय T log of R naught by R, right? K value I'll mention in terms of T half. That will be nothing but 0.693 divided by T half. That is equal to 2.303. Here I'll take T 75%. Log of R naught will be what? It will be 100. What will be R? 75% has completed. So 100 minus 75, it will be 25. Okay. 0.693 divided by T half, that is equal to 2.303 divided by T 75%. 25 ones are 25 fours are. So log of 4. Log of 4, when you check, it will be 0.6021. Okay, 0.6021. So rearrange कर लो आप. यहाँ पर क्या होगा देखो. T 75%, you take it on the left side, that is equal to 2.303 multiplied by 0.6021 divided by 0.693 into T half. जब आप ये कैलकुलेट करेंगे देखो कितना मिलता है आपको. 2.303 multiplied by 0.6021, you will be getting 1.386 divided by 0.693 divided by 693. जब आप करेंगे आंसर आएगा ऑलमोस्ट इक्वल टू 2. So T T75% इज इक्वल टू, जब आप ये डिवाइड करेंगे आंसर आएगा 2 इंटू टी हाफ, राइट। सो T75% इज इक्वल टू ट्वाइस द हाफ लाइफ ऑफ द रिएक्शन, राइट। मतलब यहाँ पे हाफ लाइफ और वेरियस परसेंटेजेस ऑफ रिएक्शंस को आप इजीली कंपेयर कर सकते हैं। जैसे कि सपोज दिस इज द रिएक्टेंट R एंड हियर इज द प्रोडक्ट। यहाँ पे होता है 50% कंप्लीशन, राइट। 50% completion यहाँ पे होता है, so it requires time equal to T half, because time required for half of the completion of the reaction or to reduce the concentration of reactant to half of its initial concentration, we call it as half life। तो ये first T half हो जाएगा। अब यहाँ पे 50% हो गया, राइट। अब 50% के बाद यहाँ पे उसका हाफ होता है। टोटली यहाँ से यहाँ तक रिएक्शन कितना हो गया, 75% कंप्लीट हो गया। 50% होने के लिए भी टी हाफ इतना ही टाइम रिक्वायर्ड था। यहाँ से यहाँ तक 75% कंप्लीट होने के लिए भी उसको उतना ही टाइम चाहिए। से फॉर एग्जांपल 50% अगर 30 मिनट्स में कंप्लीट हो गया, 75% फिर एक 30 मिनट्स लगेंगे, यानी कि रिमेनिंग 25% जो एक्स्ट्रा कंप्लीट हो रहा है उसके लिए भी 30 मिनट्स चाहिए, राइट। और यहाँ पे अब कॉन्सेंट्रेशन सपोज यहाँ पे 50 हो गया, यहाँ पे कितना हो गया 25। अब 25 का हाफ कितना होता है 12.5, यहाँ पे 12.5 होगा। अब 25 से 12.5 होने के लिए फिर से आपको 30 मिनट्स ही चाहिए। दिस इज रिगार्डिंग फर्स्ट ऑर्डर रिएक्शन, राइट, बिकॉज इन फर्स्ट ऑर्डर रिएक्शंस half life is independent of the initial concentration of the reactant. For first order reactions, half life is independent of the initial concentrations of the reactions, right। तो यहाँ पे 50% था, यहाँ पे 75 हो गया, यहाँ पे 87.5 खत्म हो गया, राइट। फिर 12.5 का हाफ यहाँ पे कितना होगा, it will be 6.25। again it requires same one more half life, so and now the reaction has completed by 87.5 plus 6.25 is 93.75. To complete the reaction by 93.75%, you require 1, 2, 3, 4 half-lives. Like this, when you come down to T 99.9%, it will be equal to 10 half-lives, right? So like this also we can relate. Instead of calculating by writing the rate constant and substituting the values, you can calculate T75% completion of reaction, it will be equal to 2 into T half। अगर आपको रिएक्शन का हाफ लाइफ मालूम है तो 75% कंप्लीशन रिएक्शन आप इजीली ये फॉर्मूले से कैलकुलेट कर सकते हैं। वेरी इंपॉर्टेंट फॉर्मूला, राइट, शॉर्टकट बोल सकते हैं। अगर आपको T87.5 कैलकुलेट करना है, टाइम रिक्वायर्ड फॉर 87.5% completion of the reaction, how many half lives it is using, 1, 2, 3 half lives, right? If you want to calculate T93.75% completion of the reaction, you require 4 half lives, right? So this is the way you can relate। अब say for example आपको T93.75 और T75% के बीच में रिलेशनशिप लेना है, तो क्या करेंगे, T93.75 is equal to how many half lives, 4 half lives, right? So I'll replace here 4 into T75 is equal to how much, 2 into T half। What will be T half, T half will be equal to T75 divided by 2, right? T75% divided by 2, right? So 2 ones are 2 twos are, so you will be getting T93.75% completion is twice the time required for 75% completion of the reaction, right? So इस तरह आप number of relationships एक्सट्रैक्ट कर सकते हैं ये रिलेशनशिप से, right? So these are all the shortcuts by which you can directly solve the numericals. If you know half-life, or if you know this time interval of what is the time required for this time and this much percentage of completion of the reaction, easily you can use this relationship and calculate, right? And if you want to calculate number of half-lives of the reaction, how many half-lives are involved in a particular reaction, you can use the formula R is equal to R naught into 1 by 2 raised to n, where n is number of half-lives. N is number of half-lives, right? Or you can also write it as R naught divided by 2 raised to n, right? N stands for number of half-lives. Okay. So here, using this formula, you can calculate how much reactant is left out after certain number of half-lives. R stands for amount of reactant left out, R naught is initial concentration, and N is number of half-lives. Say for example, first half-life, एक half-life होने के बाद कितना reactant बचता है? तो first half-life यानी कि N is equal to 1 लेंगे. One half-life period is over. So that time what happens? R is equal to initial concentration will be what? 100. So 2 raised to 1, nothing but 2. So how much reactant will be left out? 50% or 50, right? So when you want to know how much reactant will be left out after 2 half-lives, that time what happens? R is equal to 100 divided by 2 raised to 2. 100 divided by 2 raised to 2 is 4. You will get 25% of reactant will be left out. Means 75% will be finished, 25% will be left out. Okay. तो इसको अगर आप रीअरेंज करेंगे 2 raised to n is equal to what? R naught by R. 2 raised to n is nothing but R naught by R. So if you calculate over here, you can also find out how many half-lives are involved in that process. Say for example, I'll take 100 initial concentration, amount of reactant left out, I will write it as 25. Amount of reactant left out is how much? 25. So 25 ones are 25 fours are. तो क्या मिला आपको? 2 raised to n is equal to 4 आ रहा है. तो 4 आप लिख सकते हैं 2 raised to 2. तो 25% रिएक्टेंट जब बचता है तो कितने हाफ लाइफ होने के बाद उतना बचता है, अगर आपको मालूम करना है तो ये रिलेशनशिप भी यूज कर सकते हैं, जहां पे आपको 2 raised to n is equal to 2 raised to 2 मिला. Bases are same, powers can be equated, so it will be equal to 2. So after 2 half lives, the concentration left out will be equal to 25%, right? So this formula can be used to find out the amount of reactant left out and to find out how many half-lives are involved in a particular first order reaction. Okay.